Okay, so hello everyone. In this video, we will cover complete file system in operating system. So in this video, we will first discuss the introduction to file system and then file system mapping and then file allocation methods, which involves contiguous file allocation, linked list allocation and indexed allocation. And at last, a very important topic, UNIX Inode structure. It can be a lengthy video, but these concepts are important and we will discuss these in detail. So without wasting the time, let's start from the introduction to file system. First of all, if we talk about operating system, what is file system? Out of all major functionalities of an operating system, the file system is the most important system. When we say the operating system manages files inside the code of operating system, we get a module called the file system which manages all the files. If we talk about Windows has the NTFS file system. Earlier there was DOS, and in the DOS operating system there was the FAT file system. If we talk about Unix, there is Unix file system. If we talk about Linux, there is the extended file system. In today's time, we are talking about big data and large amount of data. For that, there is ZFS file system and distributed file systems. So whether we talk about any operating system, in the code of operating system kernel, you will find one module, that is the file system. So what is the first point that is covered here? Is a file system hardware or software? File system is software. If this is a software and comes under the operating system, what work does it do? It manages files. Now what is the meaning of manages here? How the data will be stored and how the data will be fetched. Like we discussed in database DBMS. What is DBMS? Database management system means which manage the data. This means how the data will be stored, and if the data is stored, then how it will be fetched. So from where does the story begin? Let's take an example of myself or an like any user. How do we manage our data? We manage our data in the form of files. Take a simple example. We copy any data with a pen drive in the form of file. Whatever we download, it is in the form of file. If you are sending email, we are also attaching a file. We send a file on WhatsApp. So if I talk about PPT, Excel, PDF, doc file, it can be of any type, MP3, MP4, PNG, JPG. So on a daily basis, what we are dealing with? We are dealing with files. Who manages those files? Who store those files in backend? Backend means the permanent storage, because we want our data to be stored permanently. It is not that like I downloaded any file or downloaded any movie and I would place it in the RAM, or we can say cache. So we will not do that. When we close the system and open it next day, we will not have that data. So I want my data to be stored permanently. So from where we have permanent storage available? It is provided by hard disk. Hard disk is permanent storage. Although SSDs are also popular, so who gets the data to be permanently stored in permanent storage? File system. So the story is, what does a user do? The user has created some file. Let's say I made doc file or Excel file or PPT, MP3, MP4, or I downloaded any file or I copied any file, whatever I am doing. The form in which I am managing the data is in the form of file. How is the user viewing his data? User views his data in the form of files. So in your laptop, what is there in C or drive or D drive? There are files only. And where are those files? These are inside folders. You will find the files inside any folder. So you can say, what is a folder? It is a collection of related files, as we call it a directory in Linux or Unix. So even if we say folder in Windows, what we call it in Linux is directory. So what do we do in this directory? We store and keep related files here. Now who is managing all these folders? The file system is managing them. So whether we talk about Windows, Linux, Unix or any operating system, the file system is managing data. How far can user see the data? User can see his files and folders, but beyond the folder, a user can't see anything. So there is a file system works. What do we have to do now? Actually, we are storing the data inside our disk, but the architecture of the disk is something else. What do we have in this disk? We have platters, surfaces, tracks on these surfaces. What do we have on the tracks? There are sectors. Actually, the data are stored in these sectors. The data which the user is creating, we want to put that data on these sectors. So the file system putting all the data on these sectors. So let's say I downloaded one file. Let's say I downloaded a movie of 1 GB. It's not necessary that I have 1 GB of space continuously in my disk. Will it be directly stored in the 1 GB file? No. So what happens here? File system mapping. When all these files come to the file system, what it does is divide these files logically into blocks. Let's say if we have a 1 GB file, so we divide it into smaller parts. Then what we do? We map those blocks with the disk. We map with those sectors inside the disk. Now it's not necessary that it is stored continuously. That I said here is block number 1 to sector number 1, block number 2 to sector number 2, block number 3 to sector number 3. Contiguous is not always possible. Maybe you can can do contiguous allocation, but it is also possible that that data is already lying here. So what are we doing? We are simply mapping that this block goes to this sector, this block goes to another sector. So let me explain you with a simple example. Let's say if I have 10 rooms, there are 10 rooms and I have 5 students, and let's say out of those 10 rooms, some rooms are already booked. Let's say this room is already booked, this room is already booked. So what I did here in the section, there are many students. By dividing them logically, with whom did I we mapped them that you go to this room and you go to that rooms. If I have 5 room already available continuously, I will send them continuously, but this is not always possible because there is already a lot of data lying in the disk. So obviously what we are doing is mapping. So the file system has a major role here. The file system stores this mapping and manages this mapping, so that when we fetch data, let's say I said student number 1 to 5 come back, means I called the whole section, and now when I'm calling the whole section, I should know that where I have sent student number 1, where did I send student number 2 and student number 3. If I will not know, then obviously I may call wrong data. So this is how the data will be stored and how the data will be fetched. This is completely mapping. We divide data in blocks, we divide the files logically, not dividing physically, we only divide it logically. And then what we did, we mapped it and then we put that in sectors inside the disk. So who is actually doing this work? This work is actually done by the file system. So file system has a major role to store and fetch data. We as a user only see our folders and our files, but the scene behind it, work behind all this, that work is actually done by file system. Now I'm going to explain attributes of file and operation on the files. Whenever we talk about file system, first of all, it is necessary to know about files which we are creating on daily basis. Any file you are creating, PDF, PPT, MP3, MP4, any file you are creating, what may be the attributes of that file or what operation are possible on that file. So what is a file? File is a collection of data, or you can say file is a collection of information. Now file operation, if we talk about what all operation we can do on that file, or you can say what operation does the file system allow, whether we talk about Windows or Unix or Linux, operations are all the same, but how do we do it? The way to execute them are different. Windows is purely GUI based, graphical user interface, but in the Linux generally we work on terminal where it is command based. Now first is creating file. We can create the file. So what we do in Windows, we do right click simply and options comes for new. We can make a new folder. Inside the folder we can make multiple files. We also have multiple application. Office, in Office there is PPT or like a doc file or Excel file. All these we can create, and further we can save it. So during saving we give it a name or give it like location where to keep it, like in C drive or D drive or E drive. So obviously based on particular location you can create that file. So as you create the file, by creating some attributes are generated. What are the attributes? Attributes are metadata. Metadata means data about data. Now what are the file attributes? We created a file. When you create some file, you right click on the Windows and go to properties. When properties open, what opens actually are attributes. This is called metadata, which means data related to data. Now the first is file name. You give it a file name, that name will be get saved somewhere. This is the metadata. And the second one is extension, or we can say file type. It may be PPT, doc, Excel file, or MP3, MP4, JPG file, any file. Third is identifier. Identifier is not the point of view of the user, it is from the point of view of the operating system. The name you give any file in identity, corresponding to that name, it is like that I have taken admission in a university, in college, so there I have a name, father's name, mother's name, marks and everything else, but what did university give to me? A roll number, a unique number. So the identifier works like that in operating system. The other one is location. We obviously like C drive, whatever location we give to the file, wherever the file is saved, this is location. The other one is size. Size of the file can be kilobyte, megabyte or gigabyte, so size also matters much. And the other one is modified date or created date. When it was created, when it was modified, when we made changes to it, all that information in modified date or created date. The other thing is permission and protection. What does permission mean? Who can access the file? Users or groups or others? These are under the permission and protection. Now other than this, we have operations like reading the file, writing the file. In reading the file means simply we have to check the data. We can't write or can't make any changes in that. Like we open a file in read only mode, we can only read the file but cannot make any changes. And now what is writing? If we talk about write, we are obviously making some changes in the data. Then deleting versus truncate. If we talk about deleting, what is meaning of deleting? Deleting means to delete a file. Deleting and truncating both are very important. Let's say you have a file, you made it in a like doc file in Microsoft Office. So in the file you have written introduction to operating system. Now if you perform delete operation, whole file will be deleted along with their attributes. All these attributes will be deleted, like metadata also will be deleted, and all the data within the file will also be deleted. But if you apply truncate, so in that case truncate, what will happen? You have written paragraph inside the file, anything you have written, all the data will be deleted, but attributes, file size, file name, file identifier will not be deleted and it will remain as say it is. Now other thing is repositioning. What is the meaning of repositioning? Our read write head, we have put any content inside the file A B C D E 1 2 3 4 5 in sequential manner, any content, and by default read write head position to the first data. Read write head means from where we have to fetch data. Now what we do, sometimes we want to skip some data. It could be A B C D E, means I want to skip this data. The pointer went to 1, or you want to pointer to go to last location. So this is actually repositioning of read write head. Now we will discuss file allocation methods. What is the actual purpose of allocation method? The file system we have, what it does. Let's say I have file name is F1, and on the other side what do we have? We have hard disk, that is your secondary storage. Now what do we do? What actually the file system does? It divides this file logically in blocks before putting it it is in the hard disk. What it will do? First it divided the data, divided the file and did logical partitions, and now what will it do with these blocks? Put it over the physical sectors on the disk. Now depending on the how we put, where we put the particular block or block of a file, in what way we are putting, that is actually allocation method. So allocation methods are of two types, contiguous and non-contiguous. And in non-contiguous we have two types, linked list allocation and indexed allocations. Now let's start with contiguous allocation. As the name suggests, we are allocating memory continuously to the block of our file. The storage we have, we are placing the data in contiguous way in our storage. So there is a simple example, we often tell a student to sit in the roll number wise in the class. So obviously what happens here, roll number 1 sat on bench number 1, roll number 2 on bench number 2, roll number 3 on bench number 3. So it allocated in contiguous way. Let me explain you with the simple example. Let's say we have 3 files A, B and C. Directory contains all the information related to files. So here I have taken only 3 information: name of file, where the file starts from, and what is the length of the file. What we have done, let's say we have a file A. So what we have done, we divided that file A in 3 parts, part 1, part 2, part 3. So obviously it becomes block 1, block 2 and block 3. This is the actual meaning of length, how much blocks it acquires in memory storage. Similarly file B we have divided into 5 parts, file C into 4 parts. So this directory contains all the information. So look what we have done, we started a file from block number 0. We have physical sectors inside the disk. So we are starting from 0 to 3 of file A. The meaning of 3 length is, first is placed at 0, second is placed at 1 and third is placed of 2. Similarly look at file B, we are starting file B from 6. Here is my 6 number block. So we started from 6, 1 2 3 4 5. So we have stored file B from 6 to 10. Similarly the file C, we are starting from 14 and we are dividing it into 4 blocks, start from 14. So we place the data contiguously like this. Now what are the advantages of contiguous allocation? It is easy to implement because we use pointers in other methods. Here neither we are using pointers or nor we are making index. Second advantage is excellent read performance. Either we are doing sequential access or direct access, both methods are easy to access. Why? At the time of reading sequentially, after reaching the desired track, it has to nothing, simply just rotate the disk and you will get the data 6 7 8 9 10. If you would have placed the data randomly, then obviously you have to change the track again and again. As often you change the track, seek time will increase accordingly. So that's why in order not to increase access time, we place the data sequentially. So as soon as we reach the particular track, just rotate the disk, you will retrieve all the data. So that are the advantages. Now what is the disadvantages? Fragmentation. Internal fragmentation is when your block or our physical block, that data we have, the size of physical block inside a disk, let's say 5 KB, and the block of your file, let's say its size of 3 KB. So you entered 3 KB data there and the 2 KB space which is remaining will not be utilized. So obviously this is called internal fragmentation, but the major problem here is external fragmentation. Now difficult to grow the file. If the file size increase, I cannot provide space to the data. Why I cannot do that? Because the next location is full. So that was the disadvantages of contiguous allocation. Now moving forward to linked list allocation. Let's start from linked list allocation. The first important point is that it comes under non-contiguous allocation. Here we are talking about linked list. So the first important point of non-contiguous in linked list is, let's say we have a file A. Now what we have to do, let's say I divided into 5 parts, block 1, block 2, block 3, block 4, block 5. Now when we will bring all these 5 into the storage, when we will bring all the blocks of the data file, then we will allocate them non-contiguously, not continuously. Let's say block number 1 comes on 2 on this particular location, the first block B1, I placed it here. That means the physical location is 2. In non-contiguous we can place it based on availability. So we placed B2 in 7. Next the block 3, let's say we placed block 3 in 9th. We placed block 4 in 11, and let's say the fifth block we placed in 14. The problem here is you enter the data in the different places in non-contiguous way. When we will fetch data, when the user will demand for file A, then how we will provide the file A to user? The file system obviously should have something mapping that where is the next block. So here if we talk about directory, what we did in directory, the file we had in directory, let's say file name was A, we will enter its start block only where it's the first block. On 2, after that how will I know that where is the second block? We will use pointer like linked list. What happens in linked list? Data and pointer points out the next block, and then data and pointer that points out the next one. Now we have to do the same thing here. So the B1 block here, this block it has the data. Here on this particular location you will find the data. Along with that data there will be a pointer. What will be the address in that? 7 will be the address in that pointer. Now what is the reason behind it? Because the next block B2 is in the 7th place. Now similarly if we talk about B2, so here I will get data also and a pointer that will be point out 9 because B3 is on 9. Similarly here will be data and pointer that will be B4. Now point B4 it will be point out 11th location in B4. The B4 block will have data and pointer that will point 14. In 14 we will have data and pointer, but the value in the pointer that will be -1. -1 means it's not pointing any further. This is the last block, so it becomes like linked list. Now what are the advantages of linked list allocation? The advantage is there is no external fragmentation, and then we can increase the file size also, which we cannot do in contiguous allocation. So these are the advantages: no external fragmentation and file size we can increase. And what are the disadvantages? The first is larger seek time. Seek time is the time to reach the desired track. So obviously larger seek time is there in linked list allocation. Random access. If we talk about random access, you have to go through whole file. Now other disadvantage is overhead of pointers. Pointers overhead will be high. Next we have indexed allocation. So moving forward to indexed allocations. As the name suggests, indexed. The meaning of index is that like we have in books. In books obviously we have content and many topics are there, but to search that topic, index is given the starting of the book, and generally in that index we have mainly page number are given along with the topic, so that you can get to that page to search data. So this is the basic concept of index. Look how we will store the data here in index. For that we have a disk here, hard disk. It is a permanent storage. Now in this permanent storage we have to enter the data. Let's say we have a file A. Now what we did to this file, we divided file A. I divided file into blocks. Now what we did, we stored this file in the disk. We stored it in physical blocks in the disk. Let's say I stored B1 in 9th, B2 in 1, stored B3 in 14, and stored B4 in 4. You can store it anywhere depending on availability. Now if I adjusted these blocks, then obviously we will fetch it to our main purpose is not to store the data, fetching the data after storing it main purpose. So how we will fetch that data? What we will do now is that we will make an index of this. The meaning of index is that the index block will tell that where my data is placed actually. So what I did, I made an index block of file A, and that index is available in 6 blocks. So here what you will get in the directory, you will get the name of file. Other than this it's other attributes, but the main important thing is that you will find index block here. And then after getting to the index block, every file will make its index block. So what are the advantages of indexed file allocation? First is it supports direct access. Now, another one is there is no external fragmentation. And what are the disadvantages? Pointer overhead and multi-level index program. Now moving forward to UNIX Inode structure. Let's get started with UNIX Inode. So what is UNIX? Operating system which uses Inode file system to keep the proper maintenance of data inside the files. Now what's the I in it? I is index and node means your block. So what we are doing here, UNIX Inode says there is a block. What are we storing in that block? We are using hybrid approach. What we mean by hybrid approach? We are storing attributes in this. Attributes means metadata, the information related to data, that is called attribute. When was the last modified, what permission, name of the file, the size of the file, path of the file, each and every information related to the file we have stored here. There is a very small amount of information, but it is important. Then we have the second block, direct block. What is meant by direct block? What we have stored in these pointers? Pointers have been inserted in this block. To whom are those pointers pointing directly? To the data blocks. We have stored their address in the direct block. That's why its name is direct. What does direct mean? The pointer you are getting here are taking you to directly to the data block. Then we have the block of single indirect. Single indirect means first you went to the pointer, you went to the data block beyond the pointer. So this is single indirect. Then what is double indirect? Double indirect means from here you went to one block, went to a data block, and then data block will not give you the data. From there you will get pointers. Again you will go from that pointer to a data block. Even there you will go not get the data. According to that, there is a third block like triple indirect. In this we are moving forward like 3 steps forward. Pointer to pointer, and then again pointer, and then again pointer, and then we are moving forward forward to the data. So this is called triple indirect. So that was the whole concept of file systems. That's it for this video. We will meet in next video. Until then, bye bye.